Good morning. Afternoon, I should say. Apologies for the delay. So in this first problem, it looks like the store is doing a 15% off $300. Right? There's a couple of ways that me and some people have talked about in regards to this. Give me 1 second. I'm going to put this little chess box, I'm going to put that under the camera so that way we got good height. We got good visibility. There we go. We got incredible visibility now. Amazing. How do I make it so that, there we go. We're going to do 15% off 300. So here's how we're going to do it. There's a couple of different ways you can do it. First, 1% of 300 is 3, right? 1% is 3, which means that 15%, all we have to do is take that 1% and do times 15. So 3 times 15 would get us 45. So we found out that $45 is 15% of 300. So we have to do $45 off 300, which ended up being $255. That was one way to do it. The other way to do it was 15% off means 85%. So the other way you could have done it is just done 85% times 300. Okay, that would have been the other way. And if you did that on a calculator, that would just as easily give you that. Okay, so you should put in 255. An email just came in, and it might be something important. So make sure that as you're watching this video, you put in 255. Okay, never mind. It was just a notification from YouTube. So we're back. So 255 was the answer. 255, no dollar sign, no nothing, just move on. Next said, how is a 15% discount similar to a 15% decrease? I'm going to say both involve subtracting or taking away 15% of an amount. The amount is getting smaller. That's another way to say it. Or it's decreasing. Okay? So if you said anything about it being 15% and the amounts are getting smaller, you are correct. I already gave feedback to a lot of people on that. If 8% sales tax is charged on the sale price, what's the total with tax? So 8%. So remember, the sales price we just found was $255. So what we're going to do is we're going to do $255, and we're going to add 8% of $255. Now, there's a couple ways we could do this. We could do, here's the classic way, 0.08 means 8%. So you do 0.08 times 255. Whatever 0.08 times 255 is, that's 20.4. So that means that your extra tax is going to be $20.40. So I'm going to do 255 plus this tax, and that should get me 275.40 cents. So you see the two steps there. The first step was to find the 8% tax. I'll label that. That's the 8% tax. Yep. And then add it onto the total there. So we did that. Okay? So it's at 275.40. 275.40. Enter. How is an 8% sales tax like an 8% increase? Both of these make the total amount increase by 8%. Yeah. One of them just has to do with money. So they both increase the amount 8%. Now, this is the problem that some people were struggling with. An item was selling for $72, and it's reduced to $60. So I want to show you something. I want you to think about this fraction. The fraction is going to be, it's going to be the total decrease. I'm going to say the total change over the original amount. That's how we find the percent change. So how much was the total change in the price? Well, the total change in the price was $12. And the original amount was $72. That comes out to be, I believe that comes out to be, you can divide them both by 12, right? I want to say that's 1/6. Okay? So you would get 1/6 if you reduced it. But again, if you went on your calculator and after you got 1/6, you used the calculator to get the decimal, you would get 0.16666 ... And this right here is a decimal. So to put it into percent form, you have to multiply by 100. So you have to put the decimal point here, which would then equal approximately, let's see if I can fit that in there, 16.7. I'm going to round up because there's a lot of 6's there, and so you would round up if it's more than 5. So 16.7, enter. These are the answers, folks. Okay, this is another percent change question. So for this, I'm not even going to erase this total change. And we're going to use this exact same fraction when doing percent change. So it says here the baseball team had 80 players show up to tryouts last year, and this year they had 96 show up to tryouts. Find the percent change. So we're going to find the percent change just like we just said. Okay? Total change over original amount. The total change from last year was 16 players more, and the original amount was the amount from last year, which was 80. And this comes out to be, I think it comes out to be 1/5. Now, this can come out to be 1/5. Also, if you reduced it, maybe you got 2/10 because you divided by 8. Whatever you got, 2/10. Now you can put this 2/10 into a calculator, 2 divided by 10. Or, if you know this is 2/10, then you know this is 20/100ths. So, and 20/100ths, you don't even need a calculator for that. You just know 20/100ths is 20%. So whether you put this in a calculator or if you simplified the fraction to turn it to a percent, either way you get 20%. No percent sign on the answer, according to assessments. They don't want the percent sign for some reason. At the student council meeting, 60 students were present. Of those, 35 were female. By what percent of males, again, I'm going to write this down, of males, if you have the word of before a group, of means out of, which means when you do your fraction, you are going to do this out of the number of males. The number of males, if you do some subtraction, you get that the number of males is 25. So out of males, that's the denominator. And now, by what number is the number of females greater than the number of males? Well, there's 35 females, there's 25 males. So that's 10 more females than males. So the fraction we should have is 10 more females out of the 25 males that we had. We could easily put this into a calculator, but I personally think multiplying the top and the bottom by 4 will be quicker, because watch, if you do that, you get 40/100ths, and that equals 40%. So that means that there are 40% more females than males. Now they ask us, so last time they asked us what percent more females are there. Now they're asking what percent fewer males are there. So again, let's do the fraction. How many fewer males are there total? There's a total of 10 fewer males. And then it says, by what percent of females? So since they say of females, we know it's going to be out of the female number. So 10/35, I am going to do 10 divided by 35 like such. And we get approximately 0.2857. 0.2857. They only want us to use the first... Oh, wait, no, I'm sorry. We got to turn this to a decimal now. I mean, to a percent. So we have this percent. Again, percents you want to multiply by 100, and you shall get the percent. So the percent here is 28.57. Now this 28.57, Hopefully at home, we only want to round to the first decimal place. So my question is, should that stay a 5 or should that be rounded up according to the next number? If you look at the next number, you would see that you round up in this case. So I'm going to do 28.6. 28.6 to 8.6. Whoa. Oh, round it to the nearest whole number. I'm sorry. It says round it to the nearest whole number. Well, the nearest whole number to this is 29. I should have read carefully. Whoops, 29. Next. Why is the percent increase and percent decrease in parts A and B different? I'm going to say when calculating the percent increase, which is when we were saying how many more females than males, when calculating the percent increase, we used 10 out of 25. However, when calculating the percent decrease, we used 10 out of 35. Because the denominator is whichever group has the word of before it. Okay? That's what I put. When calculating the percent increase, we got 10 25ths. When calculating the percent decrease, we used 10 35ths. That's because the denominator is whichever group has the word of before it. Once each day, Darlene writes in her personal diary, and she records whether the sun is shining or not. She looked back through her diary, and she found that over the period of 600 days, the sun was shining 60% of the time. So we did some quick math. 60% of 100 is simply 60. So 60% of 600, you must take that 60 and do times 6, because it's 600. So out of those 600 days, 360 were shining. I'll put a little sun there. Okay, 360 shiny days. She kept recording for another 200 days. So now instead of a total of 600 days, we had a total of 800 days. I'm going to put a little line between these. After 200 days, we had a total of 800 days. Then she found that the total number of sunny days had dropped to 50%. So on these 800 days, 50% of those were sunny. And so hopefully everybody said 50%. Well, that's half. So does that mean there were 400 sunny days total? Yes. So my question is, from here to here, 200 days passed, right? From the numerators that we got correct, how many more sunny days were those? From 360 to 400, that is 40 sunny days to make 400. So of the final 200 days, 40 of them were sunny. Henry is considering purchasing a mountain bike. He likes two bikes. One costs $500 and the other costs $600. He tells his dad that the bike that is expensive is 20% more than the cost of the other bike. Is he correct? So the one that is more expensive is $600. So he's saying, hey, the $500 bike, if you add 20% to that, you will get $600. That's what he's saying. He's saying that the more expensive bike is 20% more than this bike. Okay. Well, what's 20% of 500? Okay, first think that. So you can do 0.2 times 500, or you can just do this in your head, because check this out. I'm going to do it like this up top. Check this out. 10% of 500 is 50. You want to know how I knew that? Because 50 fits 10 times in there, and 10% fits 10 times into 100%. So you could easily find 10%. So 20% must be double that, which is 100. And is that true that if we take the cheaper bike, 500, and then we add 20%, does that equal the more expensive bike? The answer is yes, it does. 500 plus 100 equals 600. So yes, the $600 bike is 20% more than the $500 bike. Justify your answer, and this is how, that means explain your answer. So I calculated 20% of 500, which is 100. I then added 100 to 500 to see if I would get 600, and indeed I did. He is correct. Boom. So you calculated 20% of 500, then you add it on. Does it equal 600? Yes, it does. So he is correct. That's my justification. That's my explanation. State two numbers so that the lesser number is 25% less than the greater number. Oh, this one's pretty easy. I'm just going to use the easy ones. State two numbers. So I'm going to start with a really easy number. My two numbers are 100 and 75. 75 is 25% less than 100. I'm going to give you, now I'm just going to list other examples. You could do 8 and 6 because I think I saw that some people had. You can do 10 and 7.5. You can do 4 and 3. Those are just some examples, okay? Because they all would help you get 3/4, right? 3 out of 4, 6 out of 8, you know? Those are just some examples. State two numbers such that the greater number is 75% less than more than the lesser number. So I'm going to do 100 and 175. Or I could do 1,000 and 1,750. All I did was start with 100, and 75% more than that is 175. From then, I just did the same thing to both numbers. I'm going to do another example. So for example, you know how we had 100 and then we had 175? What if I double both of those? I would get 200 and 375. Okay? Submit answer. Explain your thought process for parts A and B. Can you use the same numbers for each problem? Could you use the same numbers for each problem? No, because I think... Because one of them is 75% more. And like, if I take 75% of 175, that would not get me 100. Can you use the same numbers for each problem? No. Why or why not? That's a really good question, actually. Because when you measure percent increase and decrease, these two are based on, no, how do I say this? That's not a good explanation. Let's see. Let me think for a second. Sorry, I'm picking my hair here. Let's see. Man, I'm kind of stuck. Oh, I see why. No, one of them is a 25% decrease, which changes the number by 1/4 of it, and one is a 75% increase, which changes the number by 3/4 of it. So yeah, okay, so if I do a 25% decrease, that changes the number by 1/4. Whereas if I do a 75% increase, that changes the number by 3/4. So these are completely different increases and decreases. That's what I'll say for now. Which one of these expressions would represent 10% of the original cost? Well, only one of them says 10% times cost. The other one says 90% times cost, so that's 10% off, but that's not 10% of. And then here we have C minus 0.10C, so that's like taking 10% off. So the only one that really works is the one that just says 10%. Which expression represent the final cost after a 10% decrease? Well, after a 10% decrease, that means you pay 90%. So that means the first answer works, because that's 90%, and then the third answer shows that you're taking away 10%, so that also works. Explain why the expressions you chose are equivalent. 0.90C means 90% of the cost, and C minus 0.10C means the cost minus 10% of the cost, which means 90% of the cost. So there you go. 0.90C means 90% of the cost, and so does C minus 0.10C, because that just means take 10% off, which means 90%. Boom. Create a word problem involving percent decrease so that the answer can be represented by expression 2. So expression 2. Okay, I'll create a word problem. That doesn't mean that yours has to be perfect, but I'll have one. So the second expression is 0.10C, so I'm going to use that expression. The price of a toy on clearance was 90% off, which... No, I'll do this. The tax on a toy is 10% of the cost. How much tax would you pay on a toy that costs C dollars? Oh my goodness. I'm gonna submit the answer, and boom. Here, I got like, I know you heard that. There was a lot of messages coming in. Okay, see, when a lot of messages come in like that, I worry, you know? You know, everybody? Okay. Back. Here we go. Next problem. Create a word problem involving a percent decrease so that the answer can be represented by the first expression. A toy has a 10% discount. What is the cost of the toy if the original cost is C dollars? And the answer to that is 0.90C. Boom. Tyler wants to know if he represents a situation involving a 25% decrease as 0.25x or 1 minus 0.25x. In the space below, type an explanation that would help Tyler understand the context of the word problem. Okay, so it does matter. So it matters which expression you use. The first if you are talking about a 25% decrease, the expression that should be used, if we're talking about a 25% decrease, there are a few ways to show that. One is to write 1 minus 0.25x, and one is to write 0.75x. So if you're doing 25% off, you could either write 1 minus 0.25, which means 25% off, or you can write 0.75, which is 75%. Okay? But the expression you use shows how much money you pay, not just how much is discounted. Okay, that's all I'm going to write. Cool. So that was assessment lesson 4. Lesson 3, that's all the fractions that we were doing. And I shall do that now. I'll do that now. Why not? I'll do that now because it's quick. So check this out. Solve using an equation. 49.5 is what percent of 33? So since you see the word of 33, that means you're going to do out of 33. So 49.5 out of 33. That equals 49.5 divided by 33 equals 1.5, which equals, if you move, this is a decimal, so to turn it to a percent, you have to do times 100, which means your actual answer is 150%. Okay? They don't want the percent sign in the answer, so you just enter the number. Okay? 72 is what percent of 180? So again, 72 is what percent of 180? 180 is like this, of 180, out of 180, 72. I'm going to do 72 divided by 180. That's 0.4. And 0.4, if you multiply by 100, you get 40%. And it says correct. Using an equation. What percent of 80 is 90? So they say what percent out of 80 is 90? So that's 90 out of 80. That's 9/8. And I know that if you do 9 divided by 8 on the calculator, I believe you get 1.125. If you get 1.125, you move your decimal over twice, so that way you can get your percent. So you get 112.5%. Okay? This is all fraction work. 112.5%. This year, Benny is 12 years old and his mom is 48 years old. What percent of his mom's age is Benny's age? So of his mom's age, of means 48, out of 48. He's 12. 12 out of 48 gets you 1/4 if you simplify that. And 1/4 we all know is 0.25, or otherwise known as 25%. Benny is 25% of his mom's age. What percent of Benny's age is his mom's age? So Benny's age, so out of 12, what percent is his mom's age? So his mom was 48. So 48 divided by 12 gets you 4 out of 1. 4 out of 1 equals, you guessed it, that's 400%. Okay? She is 400% of Benny's age, because 100% would mean the same age. 400% means she is 4 times older. Okay? In 2 years, what percent of his age will Benny's mom's age be at that time? In 2 years, What percent of Benny's age? So in 2 years, what will Benny's age be? Well, he's 12 right now, so in 2 years, he will be 14. So I'm going to do out of 14 because it says of his age. And his mom will be 50. So if we find out that percent, 50 14ths, I'm going to use my calculator for that one. 50 divided by 14 is 3.571. 3.571. So if I multiply that by 100 to get my percent, I'm going to get 357.1%. It says round. Does it say round to the nearest hundredth? Oh, round to the nearest hundredth. So that means I have to do one more decimal place, which the next number was 4, so 357.14. In 10 years, Benny's mom's age will be what percent of Benny's age? So of Benny's age, out of Benny's age, out of Benny's age. Benny is 12, but in 10 years he will be 22. And his mom is 48, but in 10 years she will be 58. So let's do 58 years out of 22 years to answer this 10-year question. You get 2.63636363 over and over. I'm just going to write it twice, though. Well, percent-wise, we got to move this over twice, so that way we can get a percent. So 263.636, right? So 263.64. I'm going to put 4 instead of 3, because after the 3, you see there's a 6, so I got to round up. In how many years will Benny be 50% of his mom's age? So, in how many years will Benny be 50% of his mom's age? Well, first we got to check out how much older is Benny's mom than him. So he is 12, she's 48. That means she's 36 years older than Benny, right? She's 36 years older. And for Benny to be 50% of his mom's age, he has to be half his mom's age. Now, right here, when he's 12 and she's 48, he is not his mom's age. Okay? It's going to happen a little bit later. He's not half his mom's age. In fact, she's 36 years older than him. So that means that he would have to be 36. Because check this out. Let's just try this out for a second. He's 30. If he's 36, I'm going to write this down here. If Benny is 36, his mom would be 36 years older than him still, right? That means she would be 72. Now, if he's 36 and then his mom is another 36 years older than him, isn't he half his mom's age? Isn't he half his mom's age? So in how many years will Benny be 50% of his mom's age? Well, when he's 36, that will happen. When he's 36, he will be half his mom's age. How many years is that from when he's 12 years old? So you do 36 minus 12. That should be 24. As Benny and his mom get older, Benny thinks that the percent of difference between their ages will decrease as well. Do you agree or disagree? So I think so, because when he's older, he can be like half his mom's age. Like when he's first born, he's 1 year old and she's 37. She's 37 times his age. So like when he's a real small baby, that means his mom is going to be many times older than him. But as they both grow old, she's not going to be 37 times older than him. She might only be twice as old as him later on, right? So I'm going to say the percent difference will change as Benny gets older. For example, when he is 1, getting a phone call here. Oh, no. When he is 1, his mom is 37, which is 37 times older. But later on, she is not 37 times older. because she's not 37 times older. She is just 36 years older always. If both people are old, 36 years is not a very big difference. But when Benny is a baby, it really is. You know, that's a detailed answer. Okay? Alright. Can I show answer? I think it lets you submit the answer. I don't know. I'm going to pause there, alright? I'm going to pause there for a little bit. I just wanted to give you guys that extra little boost to get your homework done. So even if it's not all complete, that's totally okay. Use this video, please, to get whatever you can done of these two, okay? Write good quality explanations. Give me a message if you need any help, alright? Thank you, thank you.